The development of the periodic table. In the early 1800s, elements were arranged by atomic weight. Until recently, there were two obvious ways to categorize elements. The first by their physical and chemical properties, and the second by their atomic weight. Atomic weight is equivalent to what we call relative atomic mass today. Scientists had no idea of atomic structure, or of protons, neutrons, or electrons, so there was no such thing as atomic number back then. It was only in the 20th century, after protons and electrons were found, that they realized the elements were best arranged in order of atomic number. In those days, the only thing they were able to measure was atomic weight, and so the known elements were arranged in order of their atomic weight. When this was done, they noticed that there was a periodic pattern in the properties of the elements, and this is where the term periodic table came from. The early periodic tables were not complete, and some elements were added into the wrong group. This was because elements were placed in the order of their atomic weight, and their properties were not taken into consideration. In 1869, Dmitri Mendeleev overcame some of the problems of the early periodic tables by taking 50 of the known elements and arranging them into his version of the table of elements. Mendeleev put the elements mainly in order of their atomic weight, but did switch that order if the properties meant it should be changed. Gaps were left in the table to make sure that elements with similar properties stayed in the same groups, and some of these gaps indicated the existence of the undiscovered elements. It allowed Mendeleev to predict what properties might be. When they were found and they fit the pattern, it helped to confirm Mendeleev's idea. Mendeleev made very good predictions about the chemical and physical properties of an element. He called this ecosilicon. We call this germanium today. The discovery of isotopes in the early 20th century confirmed that Mendeleev was correct to not place elements in a strict order of atomic weight, but to also take account of their properties. Isotopes of the same element have different masses, but have the same chemical properties, so occupy the same position on the periodic table.